Hello, my name's John O'Heal. I'm a retired professional musician, bass player, backing vocalist. I suffer from noise-induced hearing loss and tinnitus. A few years ago, I started to work as an agent for a hearing protection company called ACS Custom, which supplies custom moulded hearing protection mainly for the pro audio and music industry, as well as in-ear monitors. Singers, musicians are vulnerable to damaging their hearing or suffer from hearing loss, mainly because in contemporary music or rock and pop sort of industry, you're exposed to quite loud sound pressure levels. Obviously this is not just with regards to performance, but this is with regards to rehearsals as well. You're probably spending a lot of time rehearsing for gigs or tours, so obviously your exposure time is going to go up. With regards to the sort of sound pressure levels that I'm talking about, they're measured in decibels, which is just a logarithmic measurement of sound pressure basically. But a lot of people can say, well what is 80 decibels, what is 90 decibels? It's probably easier to get an app on your iPhone or Android smartphone and have a look. You can download various dB meters and sort of turn them on in various environments, so you can kind of understand what the sound pressure levels are that you're working in. They're not that accurate and you shouldn't use them professionally to that effect, but they give you some idea of the sort of sound pressure levels you're going to be exposed to. So with regards to what can damage your hearing, what sound levels can damage your hearing, at 85 decibels, anything over 85 decibels will start to affect the sensory hair cells in your cochlea. And it is about your exposure time. So at 85 decibels, your exposure, daily exposure should be about 8 hours, which is a normal working day, or a day's worth of rehearsals or being in the studio. As the sound pressure levels go up, obviously you need to reduce your exposure time. So an increase in 3 decibels, because it's measured logarithmically, is twice the sound pressure intensity. So the sound levels are actually doubling. So at 88 decibels, going up from 85 to 88, you should half your exposure time. So you can see then that if you're exposed to sound pressure levels of 88 dB, your exposure time has gone from 8 hours to 4. If you go up another 3 dB, 88, 89, 90, 91, you should half your exposure time again. So then you're down to 2 hours. So you've gone from 8 to 4 to 2. Playing a normal acoustic drum kit is around 90 to 93 decibels. So if you're in an environment, in a rehearsal or on stage with an acoustic drum kit, it's more than likely that those decibel readings or sound pressure levels are going to be in the low 90s. Okay, so your exposure time is really only 2 hours. So what is the damage being done in your ear? Well, mechanically there's not much that can go on with the sound pressure waves in the air going through your auditory canal, down the ear canal, and they hit the tympanic membrane, which is the eardrum to you and me, which vibrates at the same frequency as the vibrations in the air. Now behind that, in the middle ear, is connected 3 bones, which actually reduce the sort of amplitude of the vibrations to a smaller membrane that's connected to the front of the cochlea. So mechanically, that's kind of what's going on. The tympanic membrane is moving, and these 3 bones are moving as a linkage system to the membrane on the front of the cochlea. So there's not really an awful lot of mechanical damage that can go wrong there, apart from if you're exposed to sort of really loud explosive sounds, gunfire or explosions. Maybe you can perforate the eardrum, or if you've got certain viruses or illnesses can cause problems with the middle ear as well. But other than that, it's a pretty stable sort of physical mechanical system. The damage that you'll find with people working with loud music is done in the cochlea, which is beyond the middle ear, which is this, basically it's a curled up tube full of fluid and sensory hair cells, and it's all curled up and it actually looks like a snail. Within this tube there's just under 15,000 sensory hair cells, like very, very small microscopic blades of grass, and these actually move to the vibrations that have been transferred from the tympanic membrane through these bones to this little membrane on the front of the cochlea. They move in the same frequency, the vibrations, and actually cause those vibrations in the fluid in the cochlea. Now what happens is that these sensory hair cells move with those vibrations in the fluid, and obviously some respond to different frequencies. But obviously, being exposed to loud sound pressure levels, these sensory hair cells get damaged. Think of it like blades of grass or wheat or barley in a field with a strong wind blowing across the field. And obviously, when you get a storm or strong winds, the corn or the blades of grass get battered down. Now, after a while, they stand back up again, and it's the same with these sensory hair cells. After about 12 hours, 24 hours, these sensory hair cells stand up again. But while they actually have been battered down, you might find that your hearing goes like a muffled, sort of temporary noise-induced hearing loss. Certain frequencies you can't hear properly, or you might have temporary tinnitus, which is like this perception of a high-pitched ringing sound. It's basically that these sensory hair cells have been battered and damaged, and they don't know what signal to send to the brain. Now, when you're young and after about 12, 24 hours, these sensory hair cells stand back up again, rejuvenate themselves, recover, and start working again. But obviously, over long periods of time, or if you're gigging for years and years and years and keep battering these sensory hair cells, after a time they don't stand back up and they die off. And that's when you start to get dropouts of certain frequency. When these certain sensory hair cells start getting battered and die off, you get dropouts in these frequencies, and that's called noise-induced hearing loss, which is what I suffer from. Now, in the design of the cochlea, is the front of the cochlea, the front of the tube, responds to the high frequencies and mid-range frequencies. Very important to humans, because that's our frequencies that we need day to day in communication, but also, hearing our offspring cry and shout because they're going to be attacked by wild animals. So obviously the high frequencies and mid-range frequencies are more important to human beings. Further down the cochlea, it's the lower frequencies, and it actually rolls off about 400 hertz, so it's not that deep. Your perception of bass is slightly different. It's in the back of the head, and obviously you feel it, vibrations in your body. So your mid-range frequencies and your high frequencies in the cochlea take a real battering anyway in everyday life. But of course, if you're gigging and exposed to music where you've got a lot, obviously it's going to be mid and top range frequencies, vocals, guitars, cymbals of drums, snare drums. They are going to actually have an impact on damaging your hearing. So, how does this manifest itself? Over years, you may find that you actually have a problem with hearing things. Maybe it might be more apparent socially, which is what happened to me. I was in, say, quite live sounding environments in a restaurant where there's background music being played, people talking, female voices, unfortunately, mid-range frequency voices. I found that after a while I couldn't tune in on what people were saying, even though I was actually sat quite close to them. And if there was any background music going on, it was almost impossible. It was almost like being hearing drunk, because these frequencies or certain bandwidths of information were missing. It's a very strange experience. I had a hearing test. I was aware actually also I had the ringing in my ears sometimes, but I didn't really notice it that much with tinnitus. But I had a hearing test, and after I had my hearing test, sat down with the doctor, and he actually said to me, he said, have you worked in the aircraft industry? And I said, no, I've worked in the music industry at the time for just over a decade, just over 10 years. And he said, well, you've got classic noise-induced hearing loss, just the top of about 1,000 hertz, 1 kilohertz up. There's a massive drop off, more so in my right ear than my left ear. And he said, you really should think about using hearing protection. Have you used hearing protection while you've been working, you know, for the last 10 years? I said, no, not at all. And he said, well, I suggest if you want to hear your grandchildren talk, you better start protecting your hearing now. So that's when I knew I had a problem. I moved away from gigging. I carried on gigging for a while and tried some hearing protection out, but it didn't really work properly. And also doing backing vocals, the occlusion effect of like you having fingers stuck in your ears when you're singing was terrible. But then the effect also affected me working in studio situations, especially doing post-production on things that I couldn't actually hear properly on near-field monitors in the studio, the frequencies. And I found if I was involved in any post-production, especially mixing and mastering, I was always overcompensating for those mid-range and top frequencies. So I couldn't mix flat, which was terrible. So yeah, so personally and professionally, it had a massive impact on my life. So hearing protection has evolved over the last 20 years, and it's a complete industry in itself, really. I think the technology has changed. As I said earlier, what you want from your hearing protection is to just turn it down, but keep a fairly flat frequency response, or complete flat frequency response, so you can still hear everything, but it is just like turning it down. The best form of hearing protection is custom moulded hearing protection, which is where you have an earplug that's completely unique to your fitting of your ears into the helix of the pinna here and into the auditory canal, just up to the second bend. So you get complete isolation, and then you're relying on the filter to attenuate those sound pressure levels. So custom moulded hearing protection is the best. You get a perfect fit in your ears, in the helix of the ear here, and into the auditory canal, just up to the second bend of the auditory canal. So you get complete isolation, and then you're relying on the filter to just turn the sound level down, basically. You can get various different types of filter to attenuate at different levels. So you could have a 10 decibel reduction, 15 decibel reduction, or 17. You can change the filters with a professional custom moulded hearing protection. This way, a lot of session musicians that I look after, or people that do a variety of different gigs, you could be doing maybe a folk or a sort of classical concert, or a sort of a low-key small jazz trio gig. You might only need 10 decibels reduction, up to, if you're playing a heavy metal gig, or DJs that are doing drum and bass gigs where you're talking 110, 120 dB in the club. You may want a sort of a 26 or 27 dB reduction in filter. Obviously, what singers find is that if you have too much attenuation, you do get something called the occlusion effect. This is quite simply, to experience this, just stick your fingers in your ears and start talking or singing. It sounds like you're in your head and you can't hear. It's muffled, you just hear the bass frequencies, you can't really hear yourself sing properly. This is a big problem with singers using a custom moulded hearing protection, or any sort of hearing protection, the occlusion effect. With custom moulded hearing protection, especially the ACS custom earplugs, they actually are tuned to the ear canal, but also the filters do let sound go both ways. So it actually does help to compensate for that occlusion effect. However, I would say that anything above 15 decibels in attenuation, you're actually going to increase the likelihood of experiencing that occlusion effect with your hearing protection. Now this causes a bit of a problem, because really what's happening there is that you can't really use hearing protection above 15 decibels. So obviously you're in an environment of 115 dB environment, you're only going to be reducing those sound pressure levels by 15 dB down to 100. So your exposure time is only going to be about an hour. So this is a bit of a problem with singers, that you can't use high level attenuating filter type custom moulded hearing protection, which is a bit of a problem. What you really should be looking at, and a lot of singers are doing this now, is using in-ear monitors. So hopefully that's been of some help to you to raise awareness about being exposed to loud sound pressure levels and also the types of hearing protection. I think really what you need to be aware of is, you know, the environment that you're in and how loud the music is, because as I said, anything over 85 decibels is doing damage to your hearing, and obviously over long periods of time that can have a detrimental effect not only to your social life but your professional career.